Well, hello, everybody, and welcome here to Thursday in Barcelona. It's great to see all of you. We're super pleased to be having this session on HAPS in partnership with the HAPS Alliance. The whole non-terrestrial network storyline has been one of the biggest themes on show here at MWC this week. It was also the case last year, but it's really grown this year. And I think one of the things that we really wanted to do to tap into that is to talk about HAPS' role within that NTN discussion. We're going to have a panel which I'll introduce shortly, but there's so much interest around using aerial connectivity from telco operators and others to tap into consumer opportunities, B2B and IoT opportunities, and all other use cases in the public sector. We know that, and we know that the commercial activity that's happening is testament to it. But I think what we want to sort of get into even more today is how those opportunities can be unlocked. What type of business models we're looking at, taking examples from case studies, field work that is already in play. What can be learned from that as we look ahead to try and scale HAPS within this NTN framework? So we're going to get into that on the panel. We're going to have leaders from across the sector joining me up on stage shortly. Our panel will be about 40 to 45 minutes. We do, though, want this to be as interactive as possible. So towards the end of the panel, if you have questions, store them up. And then we're going to have hostesses that can bring microphones around. And please just raise your hand. So I will pause later in the panel so that we have 10 or 15 minutes perhaps for Q&A and make sure we can get your questions answered, because I'm sure some of you in the audience will have those. Okay. So just by way of introduction, my name is Tim Hatt. I am the head of research and consulting at GSMA Intelligence, which is the analyst arm of the GSMA. We cover the whole telecoms industry. But within that, the whole NTN story, be that within satellite or in HAPS, has become a major focus area. And as I say, we're following it very closely. So really pleased to be here today. Okay, let's move on to the introduction of our panel, which should be shown on the screen here. So I'm going to call them up, and we are going to get started after that. So Mr. Ken Reardon from Nokia, Greg Ewert from Stratospheric Platforms, Jeff Smith from AALTO HAPS, and Russ Vanderwerth from Aerostar. Gentlemen, if you could please come out. Okay, well, let's get comfy here. We've got lots to go through. I've got a slew of questions, and we're gonna take this discussion in a whole bunch of different ways. But Ken, I wanted to give you the chance to open us up here with some remarks from the HAPS Alliance before we get going.
Yeah, thank you, Tim. I'm also really happy to be here. I'm the president of the HAPS Alliance. I've been associated with it since we began about 4 years ago. I'll talk a little bit more about the organization in a minute, but I want to take a moment to talk about you folks. Thursday at lunchtime. Now, if that isn't an illustration of your commitment to getting the most out of Mobile World Congress, I don't know what is. So really appreciate you guys joining us for this discussion. Want to make it worth your while. Interactive discussion, absolutely what we want. So we'll have, kind of a traditional moderated thing here to help you guys get your juices flowing. But when it comes time to pass microphones around to you, please take them. I have talked about HAPS to myself till I'm blue in the face. I bore myself when I talk about something I know. So let's have a discussion. That's my request of you guys. The HAPS Alliance, as I mentioned, formed chronologically 4 years ago. 2 of the last 4 years were COVID, and therefore they don't count in my mind. Those years kind of disappeared from my brain. But today, the organization counts over 80 member companies, companies from the telecom industry, obviously. Here we are at Mobile World Congress, the aviation industry, the IT industry, really strong representation from academia, and we have regulators in our organization. So we got a really good cross-section of stakeholders in the industry that obviously bring their own particular interests and skill sets to the organization, but we share a collective vision, a collective goal of leveraging the Stratosphere as one tool to help us bridge the digital divide, which of course we talk about throughout this week. And we'll talk about the toolbox and how that particular tool fits in with the other tools in the toolbox, including other non-terrestrial network solutions and of course traditional terrestrial solutions. So it's a tool in the toolbox. We've got a very great cross section of experts up here that'll tell you about recent progresses and give you a sense of where the industry is in realizing this mission. So once again, super excited to be here. God bless you for being here at lunchtime on a Thursday. Let's make the most of the time. Let's have a great open discussion. So let's get at it.
Let's get at it. Good. Thank you very much. So let me just, before I get into questions, guys, can you just give a quick elevator overview, 30 seconds, introduce yourself, why you're here, why HAPS matters to you? Greg.
Sure, I'll start. Greg Ewart, representing Stratospheric Platforms. I'm currently the Managing Director of North America and also the Chief Commercial Officer. When we look at HAPS in our beginning, we think of ourselves as a power station more than anything. With the help of a lot of the MNOs, specifically, one of our first lead partners in Deutsche Telekom, we understood the needs that they had from the perspective of NTN and where, as Ken said, HAPS fit in that toolbox. So from a design standpoint up, we looked at the MNOs as being our number one customer that we had to meet that design for. So everything that's been designed around it right now from, as I state, the power system, which then feeds the ENOBs, which feeds the antenna, the backhaul, et cetera, has been built for that. So probably the takeaway is we're a big power station in the Stratosphere.
Jeff.
Thanks. Jeff Smith from AALTO. And AALTO is actually part of Airbus. We're a 100% subsidiary of the Airbus Defence and Space Organization. So the Zephyr platform is obviously had a long history. It's 15 years plus of development and prototyping. And right now we're sitting on just over 4,000 hours of stratospheric flight experience. Obviously it came about more from the defense side of the world, but we now believe we've got the platform that can provide long-term sustainable services and offer high persistence. And we've been working for the last 3 or 4 years on the mobile connectivity aspect, whether it's point-to-point, point-to-multi-point as a backhaul type solution, or whether direct-to-device. So yeah, we've basically got to that point. We're right on the cusp of commercial services and working with some very large customers, STC, Saudi Arabia, NTT Docomo and Space Compass in Japan. And it's a very, very exciting time to be involved in the HAPS Alliance and the HAPS layer of connectivity solutions.
Great. Russ?
Every good party needs a balloon guy, so I'm the balloon guy here. Russ Vanderwerf with Aerostar. We've been building high-altitude stratospheric balloons, so a lot bigger than the typical party ones, for 65 years. And so we've been doing stratospheric flight for a long time, a lot of START, space program, commercial, scientific tests, that kind of stuff. About 15 years ago, started working with Ken's former organization in Loon and Google to do communications and navigation with balloons in the stratosphere. And that really kicked off a whole new world for us in understanding what can be done. So we've had, since then, on the order of 3,000 to 4,000 balloon flights, doing all kinds of things that we'll talk about. and hit a nice milestone here a couple months ago. We actually had a platform aloft and navigating in the stratosphere every day for the last year. It's probably closer to 13, 14 months now. So a lot of flight heritage, a lot of good stuff that we'll talk about what we can do with it. So
Great. Perfect. Okay. I want to start with just a level set question here. And Greg, maybe I can come to you on this. You've worked you have multiple perspectives here, but walk us through, because within NTN, there are many different solutions there. There's different altitudes. You know, a lot of talk this week has also been on the satellite side of things. How are HAPS different from satellite? And both technically and the types of use cases they can serve, just so our audience understands where we're at.
Sure. And again, I go back to, starting with the NTN. Personally and professionally, a big believer in there's no one network out there that's going to meet the needs of the needs of the appetite that we see in telecommunications and information services. Now, there are different technologies at the multiple layers. If you want to start in GEO and work down through MEO, work into LEO, which is getting a lot of airplay right now, and then down into the stratosphere. A lot of it comes down to pure physics from the standpoint of link margin and what's available from each one of these areas. But I think when I look at it, they all together meet the needs of end consumers and enterprise customers from that standpoint. The differences I think you're going to find are in the application layer. So right now, if I were to look at a broadcast or a geo type network, I would never try to do broadcast services in the stratosphere, or even probably from a traditional standpoint, purpose built from that standpoint. When you start to get down and we see what's happening right now with direct to handset in the LEO standpoint, again, which is getting a lot of airplay with respect to the Apples of the world, Starlinks of the world, ASTs of the world. Those have a role to play as well. The difference, though, is going to be the performance characteristics at those applications. We see LEO right now as being ubiquitous on a global basis for the most part, but very small bandwidth. Emergency services, SMS, texting messages, things along that nature. When you start to get down into the stratosphere, again, because of the physics and being closer to the Earth's surface, you find that the technology that you can actually leverage off of, which is more attuned to, normal tower type technology with some slight modifications, allow you to fundamentally look like a tower in the sky with the performance characteristics of 5G, potentially 6G and beyond. So I think that's the big point right now that we're seeing in the marketplace, is that the stratosphere is going to unlock the needs of the MNOs that want high bandwidth, high throughput, 5G, 6G type applications.
Okay. Yeah, no, and I think this is helpful, because getting into that level of detail is important to differentiate the options out there, and I think a lot of operators will want to understand how those all sort of relate to each other and stack up. Ken, if I can come to you, so we've had we had a session on this last year, 12 months ago. There was a lot of interest then. There's even more interest now. Take us through, over the last 12 months, what has accelerated momentum in the HAPS space? Why is it getting more interest now? What's happened over that period to trigger that?
I think we can point to a few important milestones in the last 12 months. One that we talk a lot about recently, Tim, is some ITU-led radio regulatory, pretty significant milestones at the World Communication Event 2023. There were recommendations put forth that would identify significant bands for global utilization of HAPS on the service link. That was not an absolute prerequisite for direct-to-handset mobile service from the stratosphere. It had been done previously. My former employer, Google, running Project Loon, had done it prior to that year, but it is a major milestone to facilitate more of a global sort of deployment model as opposed to a very regional or customer-specific model. So that's a major milestone. What I think is more important is just some of the fruits of the labor of the investments made by many companies, many of them HAPS Alliance member companies, who have continued to put flights in the air, have continued to log out hours, have continued to advance both from a capability perspective, from a duration perspective, a quality of service perspective. This is the growing curve that an industry like ours has to go through in order to mature the technology to a point where it will meet the expectations of the customer base. And we have three representatives here that can talk about their company's individual achievements, but collectively, again, the HAPS Alliance members and beyond have continued to prove the capabilities to successfully run tests, to do, in the case of the work between the partnership of Greg's company and Deutsche Telekom, and another one of our very important HAPS Alliance member companies, successfully creating 5G links from the stratosphere running into the hundreds of megabits per second. That's significant. And when we get into, probably later in this discussion, some of the pros and cons and utilization capabilities of various altitudes of non-terrestrial networks, what you're going to see, what we are seeing, is that the stratosphere, which is a fun word that we like to say, for a lot of people, it gives you this impression of really high and really far away. But guess what? The stratosphere isn't that far away. So to create radio links, high-performance radio links from the stratosphere direct to handset to people on the ground is a much easier technical challenge than doing it from outer space. So that's why the types of performance capabilities that I just referred to have already been demonstrated to be possible. And now what we've seen in the last 12 months, and what we'll continue to see going forward, is more and more proof points, more and more hardening, cost reductions that will bring this to a place where it is commercially viable, and then you'll see the hockey stick takeoff of commercial adoption.
Yeah. And just to sort of elaborate briefly before I come to the next question on what Ken said, for those of you in the audience who want context on the altitude, a commercial aircraft will typically fly, correct me if I'm wrong, about 10 kilometers above the sea level. The stratosphere then sits, and where HAPS vehicles would sit is about double that, 20. Mm-hmm. And then you'll have LEO satellites anywhere between 550 and 1,100 kilometers above. And then you have GEO satellites, well, MEO in between, but then GEO, who sit at a fixed altitude of just under 36,000 kilometers. So we're talking an order of magnitude closer to Earth, and that brings a lot of increase in the signal propagation just through the laws of physics. Just
Tim, will you allow me to humor myself, if not the audience, with one of my fun little geometry experiments? So this is Ken's cell phone right here. It's one I use. I've got two. But if we all spin around and look at that bright light glowing in the back of the room there, imagine that's a LEO satellite. Yeah. Imagine that's Starlink back there. The distance between Starlink and this phone is what, 40 meters back there, 50 meters? To put that into proportional scale, this is how close the stratosphere is to my phone. So that gives you a kind of a visual sense of the difference in distance, and therefore the technical challenges associated with creating any link, whether it be telecommunications or Earth observation or whatever you're trying to achieve from the stratosphere. Those are the kind of geometry comparisons that we're talking about.
Jeff, you spoke about some of the commercial activity and partnerships that AALTO is involved with. Can you give us your view, again, of the technical, we're going to come to commercial in a minute, but of the technical innovations that have happened to further improve the performance of HAPS?
Yeah, sure. So obviously the Spectrum was a great thing to have globalized standard offerings, but it hasn't been a barrier. I think from my perspective, the technical elements are, a lot of them are actually in flight, and that's not a pun. Things like certification. We're a fixed wing operator, so certification of these sorts of aircraft is quite unique. They're not a drone, and they're not a commercial standard aircraft. So working with the regulators, we're having a great interaction with them to almost develop some new rule sets. So we're looking to try and get our aircraft certified within the next year, year and a half. That is going to hopefully assist others in the fixed wing space when they come to certification programs. Obviously, having the relationship we do as part of Airbus, we're quite well known for aviation. And so being able to get those hurdles out of the way is positive. I think the other thing I've seen from a technical perspective is about some of the system architecture and the software and automation. There are companies now that have spun out from Loon and others that are creating the ability to provide autonomous operations. The only, I guess, hurdle, if you want to call it that, is it's a regulatory one. So we are also very heavily working in the HAPS Alliance on the aviation aspect of how do we all operate safely and securely in this new domain of air traffic. We are, as you pointed out, above commercial aviation. That ends at 55,000 feet.
Yep.
Most of us are sitting at 60 to 75,000. Yep. So we need to have a way of making sure that if a balloon from Russ's company is over here doing some business, maybe it's their methane monitoring, for example, or whether it's, Stratospheric platforms doing some services, that we can all interact and operate in a safe fashion. So that's another one that will evolve and develop.
You prompted a next question. Russ, I want to come to you on this. So, because I think part of the value of this discussion is shining a light on use cases and applications that are possible with HAPS that are not possible with satellite, or less possible with satellite. Your company is involved, Jeff alluded to it, methane monitoring. Can you give us some color on some of the use cases you're looking to serve? And because I think that would be beneficial to a number of operators, and the trade-offs that are involved in that compared to if you were to try to do that with a satellite constellation.
Yeah, sure. So, this is Mobile World Congress, so starting a little bit with mobile applications and communication, we know that there's coverage in a lot of parts of the earth, but I think if you look at things that are regional, seasonal, underserved, infrastructure disadvantaged, that's what we've traditionally talked about with HAPS. And we're starting to see that, right? We're starting to actively work to employ that. So we have a program going with the U.S. Forest Service right now, and it's an example where they're looking to enable direct-to-device connectivity for wildland firefighters. So during fire seasons in the U.S. in the mountains, they don't have good connectivity there. And you can set up SATCOM, and LEO is a powerful tool, but if you're a firefighter who's literally out there digging trenches in the forest, you may not have the time, energy, or space to set up a satellite dish. So if we can enable or empower that person to have a connection directly on their phone, so that's what we're doing. We're flying through the HAPS, the balloon in our case. You're getting satellite connectivity down to the HAPS platform, and then direct LTE connectivity to the phone. And then doing that at a data rate that enables more than just occasional messages. We mentioned direct-to-device from LEO, but the bandwidth is limited. Again, it's that laws of physics thing. We can provide enough of a link that they can make a phone call or, for example, download. So one of the things we're doing is flying an infrared camera sensor. They can get a real-time mapping from 20 kilometers up of where that fire is at. And if you're on the ground with limited communication trying to fight that fire, that's really important information, right? So that's a good example. Jeff brought up the methane monitoring. So we just concluded a project, we're ongoing, I guess. We just concluded a flight in partnership with a company called Scepter Air, who has a data delivery platform for hyperspectral imagery. And one of the things they're doing with that is on the end customer is ExxonMobil, which is a large oil and gas company. So in Western Texas, in the United States, they have a large area of infrastructure with lots of wellheads and things where they're extracting those resources, and they need to be able to detect and quickly fix leaks. Methane, we just had the COP conference. That's one of the key drivers for global warming, and so they're trying to figure out how they can do that. So with satellites, first off, you have to have a satellite with a specialized sensor for detecting that. Now, you can do that, but you're probably not going to put up a whole constellation of LEO satellites with that kind of sensor. That's pretty expensive for what is needed. There are some satellites out there that can do that. Most of them, since there's only 1 or 2 satellites, they might be making a pass over that area once or twice a day. So the problem you have in the methane situation is you have what you call intermittent leaks, right? Where maybe some valve or something on a piece of equipment is failing and there's occasionally a discharge. Those discharges can add up to a significant amount of methane over the course of a day, but they're not happening all the time. So if you don't happen to have that satellite come over at that exact moment when that leak is occurring, you're not going to detect it. So the nice thing about using a HAPS platform is it can be persistent on station regionally. You can put a few of these aircraft or balloons or whatever over that area with the right sensor and get that real-time coverage. So there's no reason you can't combine those things, like with that Forest Service example where you have communications and imaging. Once we get the platforms to the maturity we're flying, then we're proving that it'll work. You can build out a payload stack that has multiple modes and solve several problems at once. So those are just some examples.
Yeah.
If I can add a couple of points just on the back of that. So obviously, one of the things we're seeing was we've spoken about mobile connectivity from the stratosphere, and that's a great example of Russ has just shared. But speaking with mobile operators all around the world, what we have seen is there's primarily 4 types of use case that the mobile operators are really looking in to serve. One that is coming up more and more as the world's environment changes is disaster recovery, both for the first responders, but also for the communities that are unconnected during that horrible event, whatever that may be. The second one is obviously rural coverage and infill, being able to provide white spot or coverage that, it's just very difficult to get to, either because of the terrain or because of the costs involved in building out, or low populations. And then the third one is platform mobility. So I spoke about that on Monday in a session in the smart mobility, which is because of the low latency nature that HAPS can offer, things like drones, eVTOLs, other aircraft, autonomous vehicles can all benefit from this type of connectivity. It can be very targeted. It can even be a 5G private environment. And then the last one is maritime connectivity. So being able to manage and monitor some of the shipping vessels. Obviously, border security and border patrol is very, very high on any nation with a coast. So just to add a bit more flavor about the connectivity applications that we can serve.
And I'm glad you brought up the emergency response scenario there. That has generated a lot of discussion this week, and I'm sure we're all aware of a number of deployments in place in various parts of the world to serve that. Just practically speaking, and maybe Greg, I can come to you on this. Like, let's just take that example of let's say there is a hurricane. That wreaks disaster in a given state in the United States or a province somewhere or a country or whatever. How would we envisage a HAPS setup being implemented to serve that use case? Is it scrambled in quick order? HAPS vehicles sent up to that given area. How can we how would a government or a telco think about the implementation model for that?
Sure, great question, and we're doing some work on that right now and some modeling. Probably 2 scenarios. If you have advance notice of inclement weather situations like that, smartest thing would be to get a HAPS platform in the stratosphere, which is normally above any weather conditions that would affect. In that instance, if you had a catastrophic, storm that came in and wiped out your infrastructure, part of your infrastructure that includes towers and power and diesel backup generators, et cetera, there'd be an immediate handoff. So theoretically, there wouldn't be any downtime of communications to that given area that's on the ground. The other way would be if there's events that are man-made. Right after that event happens, you could send up a stratospheric platform also into that area. You think about the time frame to go from airport to station keep. In our scenario is about 3.5 hours from that standpoint. So, it's pretty quick. And I think it all comes back to, if you think about, and you see pictures of earthquakes or disasters that had happened in the past, a lot of it is about, it's after the event, and, communications and food and fuel and things like that take days and days to get into these areas. if you have that communications infrastructure that could be either there pre-positioned or within hours, I think that's a game changer for these applications.
And if I could
Yeah, please.
jump in on this, this disaster recovery point, this is approaching ancient history now, so apologies for that. But it was 2018 when Hurricane Maria took out significant percentage of the islands in the Caribbean, including the southeast United States. Loon was in the process of doing testing in South America at the time. So there was ground infrastructure in place. But within a matter of days after Hurricane Maria took out the entire island of Puerto Rico, Loon, in partnership with AT&T and T-Mobile, lit the island back up in 3 days. And cell phone service was restored across the entire island of Puerto Rico in 3 days. And one of the fun little stories that came out of that is there were families that lived in the particularly mountainous, remote areas of Puerto Rico that never had cellular coverage. And all of a sudden, they have cellular coverage in their homes in areas where they never had it before. Now, those mobile network operators restored traditional service in about 6 weeks' time, and we flew our balloons back out of there. But that, I think, was a nice example of the capabilities that we're talking about. And I think it was Greg that mentioned, to the extent that you know, whether it be earthquakes in Japan or the Caribbean and those types of weather conditions, to the extent that you can at least statistically anticipate where you might have it, a little bit of relatively low-cost provisioning to allow a HAPS fleet to come in and to provide service when it's needed. That's a pretty cost-effective and pretty high-performance disaster planning type of investment that countries and governments should be considering.
I'm going to ask another round of questions, but I'm going to come to the audience shortly. So if you do have questions, queue them up, and I'll come to you guys shortly. There will be some mics to be provisioned if you do have a question. Jeff, can I come back to you on something? So, I'm interested in the geographic balance of where demand sits for HAPS. Can you speak to, whether it's disaster response or other use cases, are you seeing broad-based interest from telco operators in HAPS across the world? Is it more regionally concentrated? I guess first question, then bolted onto that, what do you think the outlook looks like on that level of geographic
Sure.
interest?
To be open and honest, I think the whole world can benefit from HAPS. Yeah. Obviously, from the interest that you've seen and the deals that are out in the public, there are two areas. One is disaster recovery is driving a real urgency at the moment, and in areas where obviously that are impacted, you've heard a couple already, and obviously in Japan it's one of the top priority use cases. But then you've got other areas of the world which are just vast geographies or difficult terrains. And so nations, especially sub-Saharan Africa, across the island nations through Southeastern Asia, there is a huge challenge for connectivity to be closed and offered. And we have a huge amount of discussions, I think, across all of our business units that is trying to raise the awareness of what we're talking about here. But the next stage is putting these into proof of concepts, trials and tests, as you're hearing from all of us. We're doing that all this year, next year, with a view to actually begin offering these services. The other aspect of this is the type of platform that we have. Each of us can play to different strengths, to different applications and different use cases. And so it's understanding that within these layers, which one applies to me as a mobile network operator. I think the future is extremely promising. We are projecting very, very large volumes in the next 3 to 5 years. And just like Ken said, the hockey stick, we're right on the cusp of that because the technology, the platforms, the spectrum, the regulatory are all falling into place now to enable business to be sold.
Russ, did you want to chime in on that?
Yeah, no, I think the point Jeff just made about the different platforms, one of the great things about what we're doing with the HAPS Alliance is you're getting all those people in a room. And so the more we can build common concepts, common linkages, common technologies, the goal would be if you as a customer, if you're a mobile network operator, come and say, hey, we want to do this, that we can help vector in and say, hey, a balloon might be appropriate for this, or an airship, aircraft, things like that. So, as all of these things are coming up the maturity curve and starting to do demonstrations, we'll learn more about that. But I think, that's one of the reasons we exist as an organization is to work with that. And then obviously, as Ken already mentioned, we're excited also to welcome the prospective customers so you can go learn about how we're seeing that, what the architectures we're trying to build and so forth.
Yeah. All right, well, let's come to the audience. Are there any questions from people? Yes, sir. Yes, sir. So could we get a microphone, please? And if others do, please just raise your hand and we'll come to you next. Just please introduce yourself and then your question. I think the mic's working now, sir.
Miguel Ángel García from Darwin Satcom. We're talking here in the Mobile World Congress about non-terrestrial networks, about ubiquitous connectivity. We're talking about satellites, and we're talking now about HAPS providing ubiquitous connectivity as well. But we are only talking from non-terrestrial networks and satellites. We're talking 5G, or we are talking NB-IoT. We're talking 4G++. And HAPS got the possibility of delivering 2G, 3G, 4G with different frequencies, not competing with non-terrestrial networks, and also helping even more in cases of disaster recovery. We are talking that in the case that you were mentioning in Puerto Rico, probably these people wouldn't have a high-end mobile, but the basic mobile. And we cannot ensure that for disaster recovery, the satellites will cover the spectrum. Because even if in 4 or 5 years we're lucky and we have the satellites ready to deliver 5G, you're going to require a mobile that's got the possibility of anticipating the satellite position through SIP-19 ephemeris, and that wouldn't happen with HAPS. And sometimes I hear that HAPS are only expecting to be an alternative to NTN, and I envision HAPS more as a collaborative service with NTN in order to provide, so to say, not so up-to-date generations of connectivity, like 2.3, 3G, 4G. What do you think is the position of the HAPS Association when regarding delivering 2G, 3G, 4G connectivity to unconnected areas? I'm sorry for no question.
Yeah, go.
Take a swing at that. A few different parts to what I just heard. One of the things that we talk a lot about in the HAPS Alliance is hosted payloads or multiple payloads or flexible payloads. And it would be beneficial to the economics of all participants. It will be beneficial when we get to a point where a HAPS vehicle or a fleet of HAPS vehicles are not purpose-built to a very narrow degree, to the extent that that is a 5G HAPS. One might imagine, for instance, that that's a 3GPP HAPS up there, and leveraging the type of multi-generational RAT that companies like my company, Nokia, have been investing in for years, where that particular box right there can be configured with the software to make it a GSM or a 3G or a 4G or 5G radio. That type of scenario certainly should be envisioned. The other thing that popped into my personal head as you were talking, not so much about a product or a technology thing, connecting the unconnected as Jeff mentioned, commonly makes us think of areas that just are not developed to the extent that they're a 5G company, sub-Saharan Africa, for instance. So having that sort of flexibility, as I believe the gentleman described, such that when the mission statement is to bring internet connectivity to large parts of the world that don't have it, if they don't have 5G cell phones there, then putting a 5G HAPS over the top of them isn't going to help any. But if there's device penetration of 3G, 4G handsets, which is going to be much more common, then that would be that aspect of this multifunctional HAPS fleet that would be the right thing to do in that instance.
Yeah, I just want to add another thing, that the versatility, and Ken mentioned flexibility, that's the fundamental difference between HAPS and satellite that I see, is that we bring these aircraft or balloons or airships up and down on our terms. It's not a launch it once and that's it. So when we can bring them down, not only are we replenishing the batteries, if we're using batteries for our fuel source, but also we can change, upgrade, and innovate the platforms and the services that those deliver. And so it means we have ultimate flexibility and we can maintain an innovative approach. So you're quite right. Whether it's 3G, 4G, 5G, 6G, we are technology agnostic in a sense.
Mm-hmm. Yeah, we had a customer flight 2 years ago where we demonstrated a 3G, 4G combined package for just the reason you brought up, because the geography that they were interested in, they didn't have even the 4G penetration confidence at that time, and that'll be true going forward. So.
Other questions? We can come back to you. We can come back.
It's your time, guys, now.
Yeah.
Ask
Yes, please, in the back
please.
here. This is the time. Yes, just we'll come back to you again. So,
Hi, it's Sandro Puglia from Capgemini. I saw that European Commission with the ESG funding is funding a lot of disaster recovery solution with the ESG fund. Is something that the HAPS Alliance is working on in order to deploy a HAPS solution with this funding in Europe?
Yeah, so did I hear ESA funding?
ESG, sustainability funding, because the disaster recovery solution are also part of the funding from European Commission for ESG.
Yeah. We've been working in conjunction with some of our partners, again, mainly Deutsche Telekom, on some of the ideas and funding that are coming up through ESA. I suspect possibly there's a connection that sits in between what they're doing as well as the funding source that you talked about. But I don't know an exact tie-in with respect to that. But I think on a global standpoint, we are finding that, because the governments are hearing these technical aspects of what we're talking about, funding sources, from multiple communities, be it an international organization or even regional governments, are putting forth the funding to help us do POCs and to be able to prove out this technology, number one. Number two, once the technology is proven out, I think we're also finding that there's a long-term support from a revenue standpoint, universal service funds, things along that nature, that will come in behind that will support these for long-term opportunities.
sir?
Hi, I'm Jose from Zero to Infinity. I have a question about China. It's a two-part question. So the balloon incident, how has it affected you? And also, what do you think China is doing? Because we see nobody from China in this in this event. What is China doing in HAPS that you can talk about? Thanks.
Yeah. And so just to give context, I assume you're referring to the drifting balloon that was eventually taken down over South Carolina. Okay. Yeah. Well, I'm not going to weigh in on that opinion geopolitically, but I think it's a fair question about their stance. Go ahead, Russ.
Yeah, no, we've certainly had a busy press year after the Chinese overflight of the U.S. I'll tell you, I was on more news programs than I've ever been on or ever want to be on in my life as a result of that. And there have been some posture adjustments. You know, we've flown internationally for years in different parts of the world. And I'll say since that happened, we get a lot more questions when we say, hey, we want to fly a balloon. You know, what are you doing? What are your safety and control procedures? You know, it's probably selfish from my company's perspective. We feel we have a good track record. We can show that we've got good coordination. We're under control. But it's up to level of expectation on communication, safety, and proof of heritage for sure. And there are some parts of the world where they don't want us flying, frankly, now because of that. So that's, you know, that's an impact. I think some of it is a news cycle thing, and we've even seen over the last 12 to 18 months is this cooling down, as it were, and getting back to normal. As for what they were doing, President Xi stopped taking my phone calls, so I can't comment on that directly. But it's.
I was going to say, I'd add at one point, it was the best free press for Stratospheric flight that you could have asked for, to be honest. The awareness that it brought to the wider public, and of course the drama that you saw with what happened with the fighter jets and the interception, it played out a bit like a drama on the news, right? So for us, raising awareness that actually the Stratosphere is able to be used for things like balloons and other aircraft was great news.
Yeah. And I think from a commercialization standpoint, and you can probably go over to China Mobile, their booth, you know, like no other MNO around the world, they're looking at the end-to-end stack as well. And HAPS technologies, drone technologies, they're all in their roadmap. So they're very actively involved in as much as the Western world.
We had some other hands up. Yes, there's a couple here, but come here first.
Just a quick question for Jeff. There's a demo at the NTT Docomo booth with AALTO HAPS. What's the roadmap, and how confident are you that this will happen?
100% confident. I mean, we've been working with NTT Docomo, and obviously their recently created business unit, Space Compass, looking at the market there. And it's fantastic to see what they've put on display. It's a bit like what Deutsche Telekom had last year as well. It's very similar. You know, the roadmap for us, we're looking entry into service late 25, early 26. And it's not just for connectivity either. There's many applications that could be derived for that marketplace. And that's another trend I wanted to see, which is, thanks for the quick question, but it's is that when we speak to mobile operators, probably all of us are seeing this, that they are seeing more interest from their government and even from some of their military customers within their nation's realm to offer services that are more affordable than reinventing it and doing it all over again for a separate business unit. So the commercialization is not just on the commercial sense. It is B2B. It is also government. It is also civil. Yeah.
There was another hand. We've got about 3.5 minutes left, so I want to try and get a couple more questions in. But yes, please, sir.
My name is Khaled from Latas, Saudi Arabia. I had a discussion with the AALTO team about the fact that it's a lightweight craft, and in terms of the call routing, that it'll be more like a relay station, and that it'll be communicating with a ground gateway that then routes the calls to the end destination. Is that the same with all the HAPS platforms, or is it specific to AALTO?
No, I mean, I guess the AALTO platform today, that's our current design. The future design is also with laser comms, which can extend reach between aircraft, but it can also be used for satellite connectivity over laser comms, a bit like the RF connection that I think Russ's company uses for the demonstrations he mentioned.
Yeah, it's just a question of what are the pros and cons of the platform, what can you accommodate, right? So we've flown with a little more of the stack on the balloon because we have a little more size, weight, and power available, and then we've done the exfil through either RF or through satellite. But that takes more weight, more power. It adds some latency versus the other approach. So there's just different approaches. It kind of depends on how you want to use it in the network and what the platform is and what it can support.
And just one more thought. I know we've run out of time here, but nobody has said the term heterogeneous network yet today. We recognize that term in a terrestrial network to mean a appropriate distribution of large cells, small cells, macro cells, towers, ground level, et cetera, that same concept applies here. You've got different HAPS platforms. They have different capacity capabilities, different agility capabilities. The right answer will be a combination of all of those, and that sort of heterogeneous network architecture is the vision that the HAPS Alliance is pursuing.
We got time for one final question, if there is. Is there? Yes. Okay. Last question here.
This is Diego from Swisscom here. Maybe it's a good final question. Last time, Google stopped Loon because it was not cost. It was a cost issue. Why do you think it works now? How did you get the cost down?
Well, I suppose I have some qualifications there. Consider this an opinion. When you are innovating, you have to find the right balance between time and the natural duty cycle of maturation of regulations, maturation of technology. I think we all know the kind of company that Google is. Google is a fail-fast company. It set for itself a time horizon that it was going to challenge to achieve, and as it turns out, that the impedance match between that level of patience and these sort of natural maturation curves wasn't right. I don't feel in any way bad about that, because this industry, like so many industries before us, will be a case of baton passing, right? One company brings the maturation of the capabilities to here, and the next companies will take it to there and take it to there. And you're seeing who's carrying the baton today, and I'm very proud of what Google did in order to help these guys do what they're doing today, and I'm quite confident that we're going to get there.
Yeah, we are hyper-focused on economics right now. Yeah. And, just some throwaway tidbits right now. We can replace up to, in some of our modelings, 450 towers. So when you look at the economics associated with that, from a capital outlay standpoint, that's about an 89% savings. When you think about the power and the resources that go to those towers to support them, we think from an energy consumption standpoint, we can save 90% of energy consumption. So it has to be economically viable, or you're not, from an M&O standpoint, or even any end customer standpoint, you're not going to buy the service. So that's why we're making sure that we're frictionless and we have the economic backing behind our solutions that are going to make a difference and impact the M&O world.
Well, this has been a great discussion. We could, we have to wrap it up, but we'll have time. I think hopefully the guys will be able to hang around for any questions offline. We could talk for hours, and I think we've covered a lot of ground. But suffice to say, this topic is going to keep coming. So I think we will keep that discussion going. But once again, guys, thank you very much for coming to join us. At lunchtime on the Thursday. We hope you found it useful. It was a good crowd and great set of questions. So thank you, and we will see you again next year.
Thank you, Tim.